Hello friends, today we are going to discuss how to reverse a linked list. We have already learned how to create a linked list using function and structure. Now our task is to reverse the linked list. That means change the structure of the linked list. Say for example, here is a linked list having 4 nodes containing A, B, C and D. And the first node is pointed by pointer S, which is having the address of the first node. Say for example, the first node's address is 2p, then AC is having 2p, that is pointing to the first node containing A. Now our task is to reverse the linked list. That means it will simply change the structure of the linked list. For example, here A is there. Now A is pointing to B initially. Here it will be reversed. That means B will point to A and C will point to B and D will point to C, and D will become the first node pointed by pointer S, and this node will become the last node, will point to null. So this is our structure. That means you have to change the content of next part of each of these nodes. We have already discussed that every node is created following a structure. Say for example, this is the structure following which we can create a node. Type def struct node, int info, and struct node asterisk next. That means every node would have 2 parts. One is the next part, another is the info part where you are keeping the information. And every node would be type def as nd. That means we can simply refer nd whenever we are creating or manipulating any node. So while you are reversing the linked list, there might be 2 cases. One is if there is no linked list existing. That means maybe before you create a linked list, you are calling the function for reversing it. So it is not possible to reverse if there is no linked list. Otherwise, there is a linked list existing having 1, 2 or any number of nodes. Our task is to reverse it. Now, what is the process? Say every node is containing the address of the next node. A is having the address of the B is having the address of the C. Our task is to change the content of this next part of every node. How would it be possible? Say from main, we are going to call a function reverse and we are passing the address of the first node, that is address of S. Why you are sending the address of first node? Because we have to change the content of S. S is initially pointing to the first node that is having A. After the task is over, S will point to the last node here. That means the node containing D, S will point. So the content of S would be changed permanently when you are coming back from the function. That's why, as we want to change the content of S permanently, as I always discuss, you send the address of it. You want to change the content of something permanently, you send the address of it. So that's why we are sending the address of S. Now, about the process. So this is a linked list here. Our task is to change the content of next part of every node. Say initially, the function we are entering into the function, say the function name is array. What is the function name? Say reverse. So the reverse is the function name we are entering into here, and nd type pointer, say double asterisk q. So S is pointed by q because q is getting the address of S. You enter into the function and take a pointer, say nd asterisk c, take a pointer which is pointing to the first node. So how this is possible? If we write c is equal to asterisk q, then c is getting the content of S. What is the content of S? It is the address of the first node. So c is now pointing to the first node. This is one pointer. Now we are going to change the content of next part of every node. So if you somehow try to change the content of this next part, then you are going to lose the address of the next node. That means node B. So it is safe that you take a pointer and point the next node. So how this is possible? See, C next is having the address of the next node. So you give it, we are taking another pointer, say, that is, say, asterisk R. So R is going to have the address of the next node pointed by pointer C. So C next, you are giving the content of next part of this node to R. So once this line is executed, R will point to the next node. So C is pointing to A, R is pointing to B. For this example, we are taking another pointer, say prev. Prev is another pointer which is initially pointing to null. Say prev is the pointer, ndata pointer asterisk prev, which is having null. Why it is initially having null? Because when it starts working, you see that node, after the operation, that node's next part will have null. So once you set this one, now you know that this node's address, the node containing B's address will not be lost. So you give the content of prev to cnext, say cnext equals to prev. That means now it is getting null. So it would look like that. You see, that would look like that. It is having null. It is having null. And after that, you set your prev by giving the first node's address pointed by pointer C. So once you write prev equals to C, then prev is coming over here pointing to the node containing A. Now you can move forward by taking C to the next node. How this is possible? You just write C equals to R. So once prev is set to that point node containing A, C can move to the next node. See, after that operation, after execution of these lines, what happens? A's next part is having null. This node containing B is pointed by pointer R as well as C. Prev is pointing to A, and you move forward. How you are moving forward? Simply, if you run a loop, that will simply keep on continuing until you are finishing with the linked list. So these are the steps, the 4 steps we have to execute over and again using a loop. So the loop will be like while C not equals to null. That means until the linked list is exhausted, these lines will be continued. How? You see, next time when you are coming back, C is not null, you enter into the loop, R is equal to C next. Again, R will point to the next node of B. That means R is pointing to C. C next equals to prev. Now you see the prev is having the previous node's content. That means the address of A. It is actually pointing to A. So you are giving it to C next. So C next, that means B's next part is going to get the address of the node having A. So it would be like this. You are reversing. Here the reversal is made. And once this is done, you made that link possible. Now you can proceed. You can move your prev to the next node. That means prev equals to C. So prev moves to the next node. That means the node having B. Prev is coming here. Once prev is coming here, you can move your C to the next node. That means C is equal to R. This line will be executed and C moves to this. So here we can give that arrow in the reverse direction. Initially it was like that. Now it has simply changed. Let us run the loop again to understand it more clearly. Again you are coming back. C is not null. So you enter into the loop. C next, R is equal to C next. R moves to the node having D. C next equals to prev. That means C's next part, this node's next part will have the previous node's address. That means the address of B, which is contained by pointer prev. So it is like that. And once this is done, prev equals to C, prev comes to the node having C, prev comes here, and you set your prev over here, then you can move your C without any problem. So C comes to D. So what happens? B is now linked with C. You can move from C to B and from B to A. And let us discuss about the last node also. Come back into the loop. C is not null because C is pointing to D. R is equal to C next. So what will be the value of R? Initially, D's next part is containing null. So now R is pointing to null. Whatever, C next equals to prev. You are having that link possible. D is now pointing to C. Prev equals to C. So prev comes here and C equals to R. That means C also points to null. R is pointing to null and C is now also pointing to null. C is pointing to null. So once now you come back into the loop, that condition of loop, that means C not equals to null, is violated. So you are quitting the loop. You are coming after the loop. So what to be done? You see, you have made that linked list reversed permanently. The next part of every node is changed. So the last task remains. That is what? That is, you need to make that node, previously the last node, make it as the first node. So how to do this? How it is possible? Simply give the address of D to S, but here you are not having any reference of S. S is recognized by Q. So give it to asterisk Q. Giving it to asterisk Q means you are giving it to S. What you are giving? You are giving the address of D. Who is having the address of D? Prev is having the address of D. So asterisk Q is equal to prev will complete your entire action. Now your linked list is completely reversed. You can freely go back into your main function. Now let's move to the function where we have already created the linked list. Following that structure, now we are to write the function for reversing it. So the function is reverse, and we are supposed to send address of a pointer. That's why ND double asterisk. And here in the choice, say we are asking the user to give 2 for reversing it. And here in case 2, we have to call the function reverse, and we are sending the address of the pointer S, which is supposed to point to the first node. And this is the function by which we would simply see the content of the linked list and break. So now let's write the function reverse, supposed to accept the address of S. That's why double pointer. Here we have to declare the pointers. First prev, which is supposed to initialize by null, and other pointers like C, R. Now before you proceed, you need to check the first case. You can remember whether any linked list is existing or not. If asterisk Q equals to null, that means S is containing null. So there is no linked list. So no question of reversing anything. So you write, say, no linked list and return from here. You don't have to write else. Now you have to run a loop. But before you run the loop, you need to set your C to the first pointer, that is asterisk Q. C is equal to asterisk Q means C is pointing to the first node. Now you run the loop. The loop runs until C points to null. That means the linked list is exhausted. First, our task is to set R to the next node pointed by pointer C. Once it is done, you can give the content of prev to C next C next equals to prev, and then you can set your prev to the node pointed by pointer C, and you can now proceed. C can be moved to the next node. C is equal to R. This way the loop will run until the linked list is exhausted. Once the linked list is exhausted, prev is pointing to the formerly last node, now which would become the first node now. So the address of this node to be given to S. There is no reference of S here in the function, but this S is recognized by Q. So asterisk Q is the content of S, where you are giving the address of the formerly last node, which is pointed by pointer prev this way. So once this is done, start running the program. Here it is. Say if you call the function reverse initially without creating any linked list, what would happen? It will simply tell you that there is no linked list because the content of S is, that is content of asterisk is now. Now you start creating the linked list. We already learned how to create a linked list. If you haven't seen that video, you can go to my channel and see the video. You subscribe my channel. Now we can call the function. Say we are adding another node. So your linked list is now looking like 23, 4, 6, 77. Now you are calling the function reverse by giving the choice 2. You give the choice 2. Now you see the linked list is completely reversed. That is permanently reversed. Now you see the funny thing is, again you call the function reverse by giving the choice 2. It will be same like before. That means it is again reversed. So it is up to you. You keep on choosing according to your requirement. The functions will be called and you will get your action done. But this is simply you are changing the structure of the linked list. But if you want, you can just print the content of a linked list in a reverse way without changing the content of the linked list. That means the structure of the linked list. How this is possible? See, here we are changing the structure of the linked list permanently. Why we are calling the function reverse. But if we want, we can have a linked list print in a reverse way. That means without changing the permanent structure, we can print in reverse way. How this is possible? By simply calling a function in a recursive manner. Say we are having a recursive function like that, void say rev, which is accepting the content of S. We are not going to change the content of S. So say D is the pointer, which is also pointing to the first node. You enter until D is null. That means the linked list is exhausted. You keep on moving. When D is null, that means the linked list is exhausted. You simply return. Otherwise, if you write else, from here, you are calling the function rev recursively by passing the next node's address. That means D next. Every time D next is having what? Having that next node's address. So you are calling this function rev. And what about printing? Print statement will be after that. Why? Because you are not going to print in a forward direction. So how it runs, every time you enter into the function, you check the condition. If the condition is not fulfilled, you come to that else part, and immediately you enter into the else part. You are calling the function in a recursive manner by passing the next node's address. But what will be the fate of this printf statement? That is the beauty of recursive function. It will be kept in a stack by the system. That printf statement will be kept in the stack. So you run it in a dry way. So first time you enter with the content of, with the address of A, that first node, and you enter and you are calling the function with the address of B node. But what about this? Printing of A will be due, will be pending. You go back with the address of B, enter, it is not null, Again, you are calling the function, but what about printing the B? It will be kept in the stack. You move forward with the address of C. It is not null. Again, you come to that else part. You call the function with the address of D, but what about the printf statement? It will be kept for future. And again, now D is pointing to that node, the last node, whose next part is keeping null. So come back. It is not null because it is pointing to that node. So you are calling the function with the dnext. Now dnext is null, so you are calling the function with null. But what about that printf statement? It will be kept as the top one in the stack, and you go back with null. Now this condition is satisfied, so you are returning. But where you are returning? You are not returning to the main function, because from where you call this from that line. So now every time the control will come to the previously called function. So this function is recursively called 4 times. So now this printf line will be executed from the stack. So what will be the printed? We know in stack it is last in first out. So D will be popped and printed. Then C will be printed, and then B, and then A. So this is the way by which you can keep printing in a reverse manner. Now come to the program. Here I have already, you see here, we need to declare the function void, say ref is the function name, nd asterisk, because you are not going to send the address of S. Now, just for printing, you are asking the user to give the option 3 for print reverse. You are simply printing. You are not changing the structure of the linked list. So here, in case 3, you are calling the function. What is the name of the function we have given? Ref. Okay. Ref, from where you are sending the address of S, and you call the function this to print the content of the linked list and break from here. I have already written the function. You can see this is the function. Ref this is the name. We are changing it as ref, and here also the lines we discussed. It is this. The queue is actually getting the address of the first node. Now we run it. Say first we are creating the linked list. Say this is your linked list. Now you call the function for just printing in a reverse way. Say the choice is 3. It is actually displaying both the things. That means the linked list original one, and so we should not keep that this function here, because ref function itself will print the linked list in reverse manner. So again, say this is your linked list. Now you call the function for printing, just it is printing in a reverse way. Let me run it again. Say here is a linked list. Again, we are calling it. It is reversed. But if you call the function again for printing it in a reverse way, you will get the same thing, because the original structure of the linked list remain the same. So every time your linked list will be the same. That is the difference between the previous function that we discussed, which changed the linked list structure permanently, and the later function which is displaying the content in a reverse way. So this is all about how to reverse a linked list, how to print the content of a linked list, and later we will discuss some more interesting functions in linked list for manipulation of linked list. If you feel that it is interesting, please subscribe my channel, share, link, and comment. Thank you.